What we're going to look at now is the factoring method known as difference of two perfect squares. So first thing is, what do I know is the difference of two perfect squares? Well, let's take a look at what we end up with after we look at our initial warm-up here. We have x plus 2 times x minus 2. So what we want to do is distribute. We're going to multiply this x times both items in the second set of parentheses. So we'll do x times x, and we get x squared. We'll do x times negative 2. Anytime we multiply a number and a letter together, we just kind of put them together. So minus 2x. And then we'll do the same with the positive 2. We got to multiply positive 2 times everything in the second parentheses. So positive 2 times x gives me plus 2x. And positive 2 times negative 2 will give me a minus 4. From here, we'll combine like terms. We can do negative 2x plus 2x. These will actually end up canceling out. So same number, opposite signs, they will cancel out, leaving us with x squared minus 4. So difference means we are subtracting two perfect squares. Well, x squared is obviously a perfect square. How do I know 4 is a perfect square? Well, a perfect square is any number where I can multiply a number times itself to get it. So if I think about 4, how do I get 4? 4 times 1 or 2 times 2. Because we can do 2 times 2, this means 4 is a perfect square. And we can actually take the square roots of a number in order to see what we end up getting. So if I were to take the square root of 4, I'll get 2. Now these two binomials that we started off with, notice they are the same thing in the same order. Both have x and then a 2, but they have opposite signs. One's a plus, one's a minus. These things are known as conjugates. And again, it's when I multiply two binomials together where I have the same items in the same order, just opposite signs. How do I factor a pair of a difference of two perfect squares? Well, step one, we always want to check for a greatest common factor. And if we have a common factor, we'll divide it off in order to make our life a little bit easier. So once I divide off a common factor, if there is any, I will see if we are subtracting and if we have an x squared. So as long as we're subtracting and it's possible we have two perfect squares, I will create two sets of parentheses. One will get a plus, the other will get a minus. And we will take the square root of both items in our expression. And we got to make sure that we put the square root of each item in the same order in our problem. So like up above where in our answer x squared was first, notice x is first in our parentheses. The number was second, so our number will be second in our parentheses. So what does that look like? Well, let's factor a few of these. So this first problem we have is y squared minus 16. So first things first, do we have a common factor? One's a letter, one's a number, so there is no common factor. However, we are subtracting, so we're going to see if we can do the whole difference of two perfect squares method of factoring. So if it is a difference of two perfect squares, which we are subtracting, so it's possible, we will create two sets of parentheses and take the square root of both items. So square root of y squared, anytime I take square root of something squared, what they'll do is cancel each other out. So we left with y. So y is first in our problem, so y is first in our parentheses. Square root of 16. So if you're using a calculator, on mine, the TI-83 Plus, square root symbol is in yellow above the x squared button. So we have to hit our second button and then x squared, and we'll do 16. So the square root of 16 is 4. So 4 will be the second thing in our parentheses. And last but not least, one gets a plus, the other gets a minus. From there, we check to see if we have any common factors or if we have a difference of two perfect squares within our parentheses, which in this case we don't, so we are all set with this one. Now the second problem, 100r squared minus 9, it's possible we have a common factor. We got 100, we have 9, it's possible due to how big the numbers appear. So what we want to do is check to see if we have a common factor other than 1 between 100 and 9. And we get 1. So there is no common factor that I can divide off. So next thing, do we have a difference of two perfect squares? So we are subtracting. So again, it's a possibility. If it is a difference of two perfect squares, I know I will have two sets of parentheses. One is plus, the other is minus. And I need to take the square root of both 100r squared and 9. So we'll take the square root of 100. So we get 10. But we also have the r squared there. So we also take the square root of r squared. So again, like before where I took the square root of a squared item, it's going to cancel out. So I'm only left with the letter that we're dealing with, r. So 10r. And then I'll take the square root of 9. And we get 3. So again, check for any common factors, the difference of two perfect squares within. Obviously, we don't have a difference of two perfect squares. I'm not squaring anything, and we don't have any common factors between 10 and 3. So there's that one. Now this third problem, we have 3x squared minus 27. Again, because we have numbers attached, it's possible that we have a common factor that we can divide off. So that's what I'm going to check first. I'm going to see if we have any common factors between 3 and 27. And we get 3. So this means we can divide off at least the number 3. So when I divide off the 3, remember, anytime I divide off a common factor, it goes off to the side, and whatever is left is in parentheses. Now I just want to check to make sure that there are no x's in both. Well, we have x squared and no x, so we're all set with that. So we'll divide off the 3. 3 divided by 3 is 1, so we're left with x squared minus, and then 27 divided by 3 will give me 9. From here, it appears that we also have a difference of two perfect squares. We have x squared, we are subtracting, and 9, we just learned in our previous problem, is also a perfect square. So we do have a difference of two perfect squares. So what this means is this guy, the x squared minus 9, is going to be split up into two parentheses, one with plus, the other with minus. Now the 3 on the outside is just going to come down along for the right. So 3 is still on the outside. And what we want to do here is take the square root of x squared and 9. Well, square root of x squared is just x. And then square root of 9, we just figured out in the previous problem that it is 3. So we end up with 3 times x plus 3 times x minus 3. So this is a good example of dividing off a common factor and then having to use the difference of two perfect squares factoring method. It's possible other problems will be like this that you see. Our fourth problem is a little different, x to the fourth minus 81. We're used to seeing x squared at this point. I will tell you right now, any variable with an even exponent is a perfect square. So just because we have x to the fourth doesn't mean we can't do it. 4 is an even exponent, so we can say there is a difference of two perfect squares. So if we have a difference of two perfect squares, first things first, common factors, there are none. So I will split up into two parentheses here. And I will take the square root of x to the fourth and 81. So square root of x to the fourth, unlike before where we crossed off the square root and the 2, this time because we have a number 4, we can't just cross it off to get x. Anytime I take the square root of an even exponent, I'm really cutting it in half. So half of 4, or 4 divided by 2, gives me 2. So square root of x to the 4th will be x squared. 4 divided by 2 gives me 2. So x squared, x squared. 1 is plus, 1 gets minus. And then we can take the square root of 81. And we get 9. So we end up with x squared plus 9 times x squared minus 9. So from here we want to look to see, are there any common factors inside each parenthesis? X squared versus 9, there are none. So now I want to make sure, do we have a difference of two perfect squares, or are we done? So our first parenthesis, x squared plus 9, yes, they're both perfect squares because we have x squared and 9. We saw in problems 2 and 3 that 9 is a perfect square. But the issue with this first set of parentheses is we are adding. We're not subtracting. So we can't do anything about this one. However, x squared minus 9 is a difference of two perfect squares. We are subtracting. We know 9 is a perfect square, and x squared is also a perfect square. So we actually have to do this once more. Now, I'm not doing anything with this first parenthesis, so we keep x squared plus 9. Because this is our difference of perfect squares, we have to split it up into two new parentheses. One gets plus, the other gets minus, and we take the square root of x squared and 9. So x squared, square root of x squared, again, we cut 2 in half, so 2 divided by 2 is just 1. So we have x. And then square root of 9, we saw in problems 2 and 3, that square root of 9 is 3. So we get x squared plus 9 times x plus 3 times x minus 3. 5, we get 1 minus 49x squared. Again, are we subtracting? Yes. Do we have a common factor? Well, number 1 and number 49. So there's no common factor other than 1. So it's possible for a difference of two perfect squares. So again, anytime it's a difference, we put a plus and a minus, and we take the square root, in this case, of 1 and 49x squared. Square root of 1 is just 1. So our first number will be 1, and then we'll take the square root of 49. So we have 7, and then square root of x squared is x. So we end up with 1 plus 7x times 1 minus 7x. Number 6, 36 plus n squared. Are there common factors to divide off? Number versus letter, there are none. Are we subtracting? No. Because we are not subtracting, we can't use the difference of two perfect squares method. So this one actually has no solution. Now 7 will be the last one I do with you guys. 1 over 25 minus x squared. This one looks a little bit different. So 1 over 25 minus x squared. First thing, do we have a common factor? Well, I got the fraction 1 over 25 and I got the letter x squared. So there are no common factors that I can divide off. So next thing is trying the difference of squares method. So what that means is, if we can do it, that means two sets of parentheses. One is plus, the other is minus, while we take the square root of the items in our problem. So first thing I need to do is see if I can get a nice fraction by taking the square root of 1 over 25. Again, fraction is just another way of showing division. So if I can take the square root of 1 over 25, I'll just do square root of 1 divided by 25. Gives me 0.2, and this tells me we do have a nice perfect square, because if I turn it back into a fraction, math, notice our first selection is to fraction. we get 1 over 5. So square root of 1 over 25 is 1 over 5. And then we take the square root of x squared, which ends up being x. So 1 over 5 plus x times 1 over 5 minus x. Now another way to see whether or not a fraction is a perfect square is if both numbers are a perfect square, then the fraction itself is a perfect square. So if I take the square root of 1, I get 1. So 1 is a perfect square. And do I get a nice number when I take the square root of 25? I get 5. Notice it's 1 over 5. So we have 1 over 25 as a perfect square. So difference of two perfect squares. We divide off a common factor if we are able to. And then we will create two sets of parentheses. One with a plus, the other with a minus. And then we take the square root of the items in our problem, making sure they're in the correct order.